In this video, I want to have a look at absolute value. So the absolute value of a number tells us its magnitude or its size. So we write it like this with those two little lines. So that says the absolute value of x is the distance of x from the origin on a number line. So for example, if we had the absolute value of 5, that would be equal to 5 because 5 is 5 units from the origin. The same thing if we look at the absolute value of minus 5, that would give us a value of 5 as well, because it's 5 units from 0 as well. It's just in the opposite direction. So we're going to have some equations and inequalities that involve absolute values. So our first example that we're going to have a look at is the absolute value of x is equal to 2. So that means we want to find the number, or any number that will satisfy this will be exactly 2 units from the origin, or from 0 on our number line. So if we have our 0 right in the middle here, we could come 2 units this way and we'd end up at 2, or we could come 2 units to the left and we'll end up at minus 2. But either way, both of these points are 2 units from that origin, so they'll satisfy this equation. So our solutions to that are x equals 2 and x equals minus 2. If we have a look at an inequality, we had the absolute value of x is less than or equal to 2. So the distance from the origin has to be less than or equal to 2. So if we have a look at the number line that we've just drawn up, we know that minus 2 and 2 are exactly 2 units apart, so they're going to be part of our equation because it was less than or equal to. So we'll colour those circles in. But anything that's less than 2 units will also satisfy it. So anything in this whole range along here will satisfy that inequality. So our solution to that is that x has to be less than or equal to 2 and greater than or equal to minus 2. So x has to be between those values or equal to those values. Our last example is if we had the absolute value of x is greater than 2. So in this one we use a different colour. So it has to be, the distance from 0 has to be more than 2. So we don't want it equal to 2, so we can put an open circle. We don't want it equal to 2 units from the origin, we want it more than that. So it's anything coming up this way or anything going down this way. So our solution to that equation then would either be that x is less than minus 2 or x has to be greater than 2. So it's going out towards the edges. And any values in those ranges, so anything less than minus 2, anything greater than 2, will satisfy that inequality. I want to have a look now at absolute value functions that get a little bit more complicated. So if we've got something in the form of the absolute value of x minus a, that's telling us the distance from x to a on a number line. So we're not looking at the origin anymore. So if we have a look at an example, if we had, for example, x minus 7 is equal to 3. So we want the distance from x to the number 7 to be 3. So if we have a look at our number line, we put 7 in the middle there. If we go 3 units right, we'd end up at 10. It's 3 units that way. If we go 3 units to the left, we'd end up at 4. So the two numbers that satisfy that absolute value equation would be x equals 4 and x equals 10. I'm sure you can imagine though that drawing up a number line every time, especially when these get more complicated, isn't the best way to do things. So let's have a look at how we can do it algebraically instead. So with this equation, what that means is that x minus 7 could be equal to 3, or x minus 7 could be equal to minus 3. Then we're going to go through and solve both of those. So we'd add 7 to both sides on this one, and we'd end up with x equals 10. And we'll add 7 to both sides on this one, and we'd end up with minus 3 plus 10 would give us 4. So we've still ended up with the same solutions as we did when we drew our number line, but we're doing it algebraically instead now. Let's have a look at a few more examples. Our next question says the absolute value of 2y minus 1 is equal to 5. So solving that algebraically, we're going to have 2y minus 1 is equal to 5, or 2y minus 1 is equal to minus 5. Then we're going to solve them both, so we'll add 1 to both sides, so 2y is equal to 6, and then divide by 2, and we'd have y equals 3. Do the same thing over here, so add 1 to both sides, and we'd have 2y is equal to minus 4, and then divide by 2, and we'd end up with y equals minus 2. So we've got two solutions there that satisfy that equation. Let's have a look at a few inequalities. So if we have 2y minus 1 is less than 7. So this one's a little bit trickier the way we have to lay it out. Because it's less than 7, like we did in that first example, the value of y that satisfies that will be between two values. So our 2y minus 1 is going to have to be less than 7, but it's also going to have to be greater than minus 7. So now we're going to solve this all together. So we're going to add 1 to all three things. So we'd end up with minus 6 is less than 2y is less than 8. And then we're going to go through and divide everything by 2. So we'll end up with minus 3 is less than y is less than 4. So any value of y that's bigger than minus 3, but it also has to be less than 4, will satisfy that inequality. Last example, so we have the absolute value of 5b minus 7 is greater than 3, or greater than or equal to. So when it's a greater than or equal to, we're going to have two separate answers. So we're going to have 5b minus 7 is less than or equal to minus 3. And we're going to have 5b minus 7 is greater than or equal to 3. So on a number line, that's going to look like our main number that we're focusing around, and it's coming up this way and down this way. So there's this gap in the middle, and that's why we have to have two separate ones. So we're going to solve them both now. So we're going to have 5b. We're going to add 7 to both sides. We're going to end up with 4. So b is less than or equal to 4/5. And then in this one, we'll have 5b is greater than or equal to 10. So b is greater than or equal to 2. Okay, so down here, we've got 4/5. And over here, we've got 2. That's a few examples of solving absolute value equations and inequalities.